Allah, the most gracious, the most merciful. As Muhammad, peace be upon him, narrated, if anyone travels on a road in search of knowledge, Almighty Allah will cause him to travel on one of the roads of paradise. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your wonderful support to make this channel a grand success. We are a family, a partner. Please share and subscribe our channel if you haven't done so far. We as a team can work together to convert challenges into opportunities and opportunities into success stories. These success stories can be monetized into value addition in the world by large. Thank you very much for your precious time. Today I am going to discuss my lecture number 6 on fluid catalytic cracking FCC unit. Warning a pathway, delivering on commitment, differentiated performance, enabling profit optimization process, lecture number 6. Before my lecture, I used to read a Quranic verse. Qala Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli Allahumma Rabbi zidni ilma. O my Lord, open my chest and ease my task for me, and loose a knot from my tongue that they may understand my saying. Allahumma Rabbi zidni ilma. O Allah, advance me in my knowledge and true understanding. Okay, fluid catalytic cracking, lecture number 6, FCC unit, a process of flow descriptions. Okay, key takeaway points from lecture number 6. First, flue gas heat recovery, main column, HCO heavy cycle oil, light cycle oil, and heavy naphtha pump around and product circuits. Okay, flue gas heat recovery. The purpose of the flue gas heat recovery is to generate high pressure steam by cooling regenerator off gas. From the regenerator, the flue gas is routed via a flue gas slide valve to the orifice chamber. The orifice chamber is a cylindrical vessel equipped with series of perforated grid plates to reduce the pressure from inlet to outlet. By reducing the pressure drop across the flue gas slide valve, their operating life is greatly extended because there is no sudden acceleration of the catalyst bearing gas stream. Next is that the flue gas enters the flue gas duct of flue gas system generator and is cooled by a boiling water on the tube side. The cooled flue gas steam is routed at the flue gas treatment system for further processing. Before entering the flue gas stream generator, a boiler of feed water is preheated in exchange to low and medium pressure steam. In the economizer tubes, the boilers of feed water is further preheated and enters the steam drum. The water in the steam drum feeds the evaporator circuit for generation of a saturated high pressure steam. Okay, level control. The LIC, level indicator controller, signal from the steam drums is summed with the steam flow signal, leaving the steam drum to control the required boiler feed water influx to the economizer. That is a 3-element control. When the boiler steam flow is less than 28% of the designed load, the boiler feed water flow is only controlled by the level of steam drum 1-element control. From the steam drum, a continuous blowdown steam is withdrawn to the continuous blowdown drum to control accumulations of impurities in the boiler water. Steam leaving the steam drum is mixed with steam from main column bottom steam generators and catalyst cooler steam disengage a drum. The combined steam is routed via steam dryers to the superheating coils of the flue gas systems. So the generator, when the steam temperature is increased above saturation, a part of the steam is cooled between the superheating sections by temperatures located in the steam drum to keep TIC, temperature in controller, the outlet temperature of the secondary final superheat constant. The generator superheat steam is routed via battery limit to power generator unit for driving a turbine connected to the generator. Okay, next is the main column. Okay, main column. What's the purpose of main column? The main column is the first step in the product separation sequence. The superheated reactor of vapors need to be cooled so that fractionations can be conducted. In large measures, operation of the main column becomes an exercise in controlled heat removal coupled with a sufficient liquid vapor contacting to affect the desired degree of fractionations into desired product streams. Namely, a main column bottoms is called the MCB, heavy cyclic oil HCO, light cycle oil LCO, heavy naphtha HNA, unstabilized gasoline and wet gas MCB, HCO, LC, and HNA are taken as a product directly from the main column. Although HCO is not removed from the unit as a product stream. The LCO and HNA are steeped in side-cut steepers for flash point adjustment. The unstabilized gasoline and wet gas are subjected to further separation in the gas concentration section. The arrangement and integrations of a heat exchange from the main column is described in my next slide. Okay. Product and side cuts of main column. Number 1. Overhead OVHD. Taken from a tray number 1 in vapor forms and returned to tray number 1 in a liquid form. Number 2 is the heavy naphtha HNA taken from tray number 6 and spilled back in tray number 7 in liquid form after exchange of heat and returned to tray number 4 in liquid form. Number 3, light cycle oil LCO taken from tray number 21 in a liquid form and returned to tray number 22 after exchange of heat and returned to tray number 19 in liquid form. Heavy cycle oil HCO taken from below tray 29 and returned to spill back in above a tray 30 and return to tray heat exchange on above 27. Last MCB main column bottoms taken from a tray 38 and then after heat exchange return back to tray 34 in liquid form. Main column bottom. The main column bottom system is designed to de-superheat the reactor of vapors, condense the bottom product and scrub interned a catalyst or particle or fines from the reactor product gases. Main column bottoms MCB is removed from the bottom of the main column and pumped by a main pump bottom circulation pump to the main column bottom steam generator. The heat exchange in the steam generator is controlled by flow controllers. The vapors are de-superheated by circulating a large stream of cooled auxiliary oil over the disk and donor trays where it acts to de-superheat the reactors of vapor as well as flush catalyst fine out of the column. The cooled bottom circulation rate control is normally set at 120% to 150% of the feed rate of 37 meter cube per hour per meter of the column diameter, depending on the column diameters, which is the grade. The bottom temperature is maintained by TIC, temperature controller, at 360 to 370 degrees Celsius, which is equal to 680 to 700 degrees Fahrenheit. To minimize a coking in the slurry circuit, a cooled stream of circulating a main column bottom taken from the outlet of the steam generator can be written as a quench the main column bottom to maintain this temperature when necessary. The minimum spillback is provided for minimum slurry circulation during turn down operation. This ensures enough oil is returned to main column adequately covering the disk and donor trays, thereby cleansing the reactor's vapors of catalyst of fines and preventing a coke formation on the disk and donor trays due to insufficient liquid flow over the trays. During the normal operation, the heat inputs from the circulating main column bottoms to the steam generator will be set by product and a process concentration. Heat input to the steam generator is the only variable available to operate for adjustment. Okay. Bottom flows to the steam generator can be adjusted to change the amount of heat rising up the column, thus increasing or decreasing the column top reflux rate, which acts to heat balance the column. Each exchanger in the main column bottoms a pump around circuit designed for oil containing catalyst particles. Main column bottoms a flow through the exchanger on the tube side, and the velocity must be kept between 1.14 meter per second to 2.13 meter per second for state tubes and between 1.1 to 1.75 for a U-tube exchangers. If the oil velocity falls below the minimum, catalyst will begin to accumulate on the tube walls and slowly plug the tube wall, greatly reduce heat transfer. If the velocity is above 2.13, the tube walls may experience erosion leading to premature failure. The rates required to meet these velocity must be calculated for each exchanger before startup. Bottom product withdrawn on a level of flow control cascade loop to maintain a steady bottom level in the main column. The product stream is cooled by heat exchanger with a boiler feed water and the exchange with a cooling water in the spiral heat exchanger. Main column bottom product, a pump transfer the slurry product to the battery limit. A spillback line with flow control to the main column ensure a minimum flow of the pump. A continuous blowdown stream is withdrawn to the continuous blowdown drum to control accumulation of impurities in the boiler water. Okay, HCO, heavy cycle oil HCO and pump around circuit. Heavy cycle oil HCO is withdrawn below tray 29 of the main column. This side stream is exclusively withdrawn for heat removal from the main column and not used as a product. HCO is circulated by heavy cycle oil circulation pump to provide the heating medium for the debotonizers reboiler adjusted by flow control, the naphtha splitter or low reboiler adjusted by flow controller, and heavy naphtha stripper adjusted by flow controller to cool HCO steam are combined in HCO returned header and transported back to the main column above a tray 27. The amount of HCO not used for heat transfer to the gas concentration section and the reboiler is directly routed back on level of flow control to the main column above tray 30. Okay, LCO pump around and product circuit. Light cycle oil LCO is withdrawn below a tray 21 of the main column. The steam is spilled into a circulating steam and a product stream. The product stream is fed to the top tray of the light cycle oil stripper under a level controller. The column is equipped with 6 valve trays. Light ends are stripped by means of a medium pressure steam and returned to the main column below tray 21. The stripper LCO is pumped by light cycle oil product pump to LCO product of boiler feed water exchanger, where it is cooled against a boiler feed water. The LCO product is pumped under a flow control across battery limit directly to other unit that is called the LCO hydro treat, or the other unit or storage side by controlling through FCC. after further cooling by light cycle oil product cooler. The circulating LCO steam is pumped by light cycle oil circulating pump. Circulating LCO is used as a heating medium for debotonizers, feed exchanger, adjusted by flow control, and naphtha splitter upper reboiler adjusted by flow controller. A sub steam from the LCO, return steam from the other side is used as absorbent for sponge absorber. It is a cooled in sponge absorber, lean oil versus a rich oil exchanger, and lean oil pump provides the pressure to admit the lean LCO under a flow controller valves from the light gas into gas concentration section. The rich LCO leaves the column bottom under a level controller and recovers heat in exchanger with lean LCO. The cooled LCO steam from the coolers and the rich LCO from the other side combined in a LCO return header and transported back to the main column above a tray 90. The amount of LCO not used for heat transfer to the gas concentration section is directly routed back on level of flow control to main column above a tray 22. Okay. Heavy naphtha pump around and product steam. Heavy naphtha HNA is withdrawn below a tray 6 of the main column. The steam is spilled in circulating steam and product steam. The product steam is fed to top tray of heavy naphtha steeper under a level controller. The column is equipped with 6 valve trays. Light ends are steeped by means of vapor generated in heavy naphtha steeper reboiler in heat exchanger with circulating HC. The light ends are returned to the main column below tray 6. The steeper HNA heavy naphtha is pumped by heavy naphtha product pump. The heavy naphtha is cooled together with the bottom product naphtha splitter by the heavy naphtha product cooler and against a cooling water in heavy naphtha product trim cooler. The HNA product is routed a flow controller via battery limit to other unit, that is a gasoline hydrofunctional or storage tank. The circulating HNA steam is pumped by heavy naphtha circulating pump. Circulating heavy naphtha is used as a heating medium for the heavy naphtha raw oil exchange. Adjusted by the flow controller, the required flow for heating the raw oil depends on the raw oil charge from storage. In the cooled feed design case, a more heavy naphtha is required than in the hot feed design case. To ensure a smooth operation of the main column, in both cases, a sub-steam of HNA heavy naphtha can be cooled in a heavy naphtha pump around a cooler. Both cooled HNA steams from other cooler and are combined in HNA return head. Okay, main column overhead system. The overhead vapors are loaded with substances such as ammonia, sulfides, cyanide, chloride, and phenols, which pose a corrosion or follow grease. As most of these substances are readily soluble in water, they are removed from the gas stream by injecting wash water. The overhead vapors from the main column together with injected water, wash water are partly condensed in main column overhead condenser. Separation of the gas and liquid phase is accomplished in main column reflex drum. Moreover, the water, wash water and condensed steeper steam from the reactor and side column are separated in this reflex drum and collected in the water boot. The liquid hydrocarbons are pumped by main column reflex pump. One part is routed back as a reflex to the main column. A temperature flow cascade control loop is applied to control the reflex rate. The other part of hydrocarbon liquid not used as a reflex is a pump on a level controller to maintain a column trip condenser. It is combined with gas leaving the reflex stem and with water from the boot, which is a pumped level control LSC by reflex stem sour water pump. The mixed phase steam is further cooled in a main column, a trim condenser, engaged a cooling water and directed to the main column receiver. In this term, the gaseous hydrocarbon phase is separated from the liquid hydrocarbon and water phase. The sour water from the boat is transported across battery limit to other unit that is called the sour water stripper by sour water pump under a level controller. The liquid hydrocarbons are routed to a primary absorber by main column and net overhead pump under a level and flow control cascade loop. Okay, this is my last slide. The gaseous overhead product is transferred to compressor suction drum. The reactor product contains a large quantity of gas and gasoline which passes through the main column as a vapor. The gasoline is condensed and pumped to gas concentration sections with some of its returning to main column as a reflex. The gasoline will affect the tower pressure, but the major control point is the gas stream, which is compressed and sent to the gas concentration section. The gas flow is controlled by two control systems. One is a pressure control, that is a Ph.D located at main column receiver, which manipulates the butterfly valves on the suction side of the wet gas compressor. The other control system is the anti-surge control of the compressor. Both controls are linked together by different type of surge control systems to keep a pressure at a receiver as constant as possible and to minimize the gas flow via the anti-surge control valves. Proper overhead control is a must as the reactor floats on the main column a back pressure, which is a turn depends upon the pressure in the receiver. If the compressor goes down, the pressure in the main column will quickly rise because the gas of the reactor cannot get out. A separate control system, PIC, called the overpressure relief valve is provided to give the gas a low pressure outlet. It's linked or connected to the flare head system. Conclusion. What we have discussed today. First, flue gas heat recovery, main column bottoms, HCO a pump around circuit, heavy cycle oil, then LCO light cycle oil pump around and product circuit, HNA heavy naphtha pump around and product circuit. Main column overhead system. Our next topic, we're going to discuss wet gas compressor and high pressure receiver, gas concentration recovery, gas concentration fractionation, and gas concentration. These are a few references here. Okay, this is my last slide. Please send me your feedback at comments.masood.dr@path.edu. Please do not hesitate and send me your input. I have also provided my WhatsApp number. Thank you very much and stay blessed.